The period between 1980 and 2000 witnessed a dramatic transformation in aviation. This era was more than just a continuation of the jet age. It was a period of accelerated progress. Technological innovation was a defining characteristic of this period. It was a time when the industry grappled with new challenges and opportunities, from the rise of digital systems to growing concerns about environmental impact. The aviation industry witnessed a fundamental shift during these 2 decades. The advancements weren't just about making planes faster or more efficient. They were about revolutionizing how aircraft were designed, flown, and operated. This period saw the introduction of groundbreaking technologies that reshaped the very fabric of the industry. The changes were so profound that they rippled through every facet of aviation, impacting manufacturers, airlines, passengers, and the environment. These 2 decades also saw the industry confront new challenges. The environmental impact of air travel became a major concern, leading to tighter regulations and the search for sustainable solutions. At the same time, the end of the Cold War ushered in a new era of global cooperation, leading to the formation of international alliances and the rise of code-sharing agreements. This period laid the groundwork for the aviation landscape we see today, where technology, environmental consciousness, and global interconnectedness are paramount. One of the most significant breakthroughs of this era was the introduction of glass cockpits. This revolutionary technology replaced traditional analog instruments with digital displays, providing pilots with a more intuitive and information-rich interface. Glass cockpits enhanced situational awareness, reduced pilot workload, and improved flight safety. These digital cockpits, with their colorful displays and sophisticated systems, marked a radical departure from the past, ushering in an era of unprecedented technological sophistication in the cockpit. The advent of digital systems extended beyond the cockpit. Fly-by-wire technology, which replaced mechanical flight controls with electronic systems, became increasingly prevalent. This innovation allowed for more precise aircraft control and enhanced maneuverability. The digital revolution also led to the development of sophisticated autopilot systems, capable of handling a wider range of flight tasks, further reducing pilot workload and enhancing safety. These advancements weren't just about replacing old technology with new, they fundamentally altered the way aircraft were flown and controlled. The integration of digital systems transformed the aviation landscape. It paved the way for more efficient aircraft operation, enhanced safety, and opened up new possibilities for automation. This digital revolution was not just a technological leap, it was a paradigm shift that redefined the relationship between pilots and their aircraft. The transition to digital systems was a gradual process, with early adopters paving the way for widespread acceptance and implementation. The period from 1980 to 2000 also witnessed significant advancements in aircraft engine technology. The quest for greater fuel efficiency and reduced noise pollution drove innovation in engine design. High-bypass turbofan engines became the industry standard, offering a significant improvement in fuel consumption and noise reduction compared to their predecessors. These engines, with their larger fan diameters and more efficient combustion processes, were a key factor in making air travel more economical and environmentally friendly. The development of new materials played a crucial role in engine advancements. Lightweight composites, such as carbon fiber, found increasing use in engine components, reducing weight and improving performance. These materials allowed for the construction of lighter and more durable engines, contributing to overall aircraft efficiency. The continuous refinement of engine technology led to a steady increase in thrust-to-weight ratios, enabling aircraft to carry heavier loads and fly longer distances. Engine advancements were not just about incremental improvements. They were about pushing the boundaries of what was possible. The development of powerful and fuel-efficient engines was essential for the expansion of air travel and the introduction of new aircraft types. These advancements in engine technology were a testament to the industry's commitment to innovation and its focus on meeting the evolving demands of air travel. The period between 1980 and 2000 witnessed an unprecedented expansion in commercial aviation. The deregulation of the airline industry in the United States and other parts of the world led to increased competition and lower airfares, making air travel accessible to a wider segment of the population. This period saw the rise of low-cost carriers, challenging the dominance of traditional airlines and further stimulating market growth. The combination of deregulation, technological advancements, and economic growth created a fertile ground for the rapid expansion of commercial aviation. The growth in air travel fueled the demand for larger and more efficient aircraft. Wide-body jets capable of carrying hundreds of passengers became increasingly common on long-haul routes. The Boeing 747, with its iconic hump, remained a symbol of long-distance air travel, while newer wide-bodies, such as the Boeing 767 and Airbus A300, offered airlines greater flexibility and efficiency. The introduction of these aircraft revolutionized long-haul travel, making it possible to connect distant cities with non-stop flights. The expansion of commercial aviation was not without its challenges. The industry faced growing pains, including airport congestion, air traffic control limitations, and concerns about the environmental impact of increased air travel. Despite these challenges, the period from 1980 to 2000 was a golden age for commercial aviation, marked by unprecedented growth, technological innovation, and the democratization of air travel. While commercial aviation flourished, military aviation underwent a period of rapid technological advancement. The Cold War rivalry between the United States and the Soviet Union fueled a relentless pursuit of technological superiority, leading to the development of highly sophisticated aircraft. Stealth technology emerged as a game-changer, enabling aircraft to evade radar detection. The Lockheed F-117 Nighthawk, with its angular design and radar-absorbent materials, became an icon of stealth technology, demonstrating the potential for aircraft to operate undetected in hostile airspace. The development of advanced fighter jets was another hallmark of this era. The F-15 Eagle and F-16 Fighting Falcon, both products of the United States Air Force's lightweight fighter program, became mainstays of air forces around the world. These highly maneuverable and technologically advanced aircraft set new standards for air combat capability. The Soviet Union responded with its own advanced fighters, including the MiG-29 and Su-27, creating an intense competition for air superiority. Military aviation also saw the increasing use of unmanned aerial vehicles, or UAVs. Initially used primarily for reconnaissance, UAVs progressively took on more operational roles, including surveillance, targeting, and even combat missions. The development of UAVs marked a significant shift in military aviation, offering the potential for remote-controlled warfare and reducing the risk to human pilots. The period from 1980 to 2000 witnessed a technological arms race in military aviation, with stealth technology, advanced fighter jets, and the emergence of UAVs shaping the future of air warfare. The period from 1980 to 2000 also witnessed a growing trend towards global cooperation in the aviation industry. The end of the Cold War created a more favorable environment for international collaboration, leading to the formation of airline alliances and the rise of code-sharing agreements. These partnerships allowed airlines to expand their networks, offer more seamless travel experiences to passengers, and achieve greater economies of scale. The formation of alliances such as Star Alliance, oneworld, and SkyTeam marked a new era of global interconnectedness in the airline industry. Code-sharing agreements allowed airlines to market and sell seats on each other's flights, expanding their reach without having to operate their own aircraft on every route. This practice benefited both airlines and passengers, providing greater choice and flexibility in travel planning. The rise of alliances and code-sharing reflected a growing recognition of the importance of global cooperation in the aviation industry. These partnerships were instrumental in creating a more integrated and efficient global air transportation network. The trend towards global cooperation was not limited to commercial aviation. International collaboration extended to areas such as air traffic control, safety regulations, and environmental protection. The International Civil Aviation Organization, or ICAO, played a key role in fostering cooperation among nations, setting global standards for safety, security, and environmental sustainability. The period from 1980 to 2000 saw the aviation industry move towards a more interconnected and collaborative model. paving the way for a more integrated global air transportation system. The rapid growth of aviation during this period brought with it growing concerns about its environmental impact. Aircraft engines, particularly older models, were significant contributors to air pollution. Emissions of greenhouse gases, such as carbon dioxide, contributed to climate change, while other pollutants, such as nitrogen oxides, had detrimental effects on air quality. The increasing volume of air traffic amplified the environmental impact, making it a pressing issue for the industry and regulators. Noise pollution was another major concern associated with aviation. Aircraft noise, particularly during takeoff and landing, had a significant impact on communities near airports. The noise generated by older aircraft engines was particularly problematic, disrupting sleep, affecting quality of life, and raising concerns about potential health impacts. The growing awareness of noise pollution led to stricter noise regulations and the development of quieter aircraft engines. The environmental impact of aviation became a subject of intense scrutiny and debate. Environmental groups raised concerns about the industry's contribution to climate change and air pollution, while the industry faced growing pressure to adopt more sustainable practices. The period from 1980 to 2000 witnessed a growing recognition of the environmental cost of aviation and the need for the industry to address these challenges. In response to growing environmental concerns, the aviation industry embarked on a quest for sustainability. Airlines, manufacturers, and regulators worked together to develop and implement measures to reduce the environmental footprint of air travel. Fuel efficiency became a paramount concern, driving innovation in aircraft and engine design. The introduction of new materials, such as carbon fiber composites, allowed for the construction of lighter and more fuel-efficient aircraft. Engine manufacturers focused on developing engines with lower emissions and reduced noise footprints. High-bypass turbofan engines, with their improved fuel efficiency and reduced noise output, became the industry standard. The quest for sustainability also extended to operational practices. Airlines implemented measures to optimize flight routes, reduce fuel consumption, and minimize ground operations, all contributing to a reduction in emissions. The pursuit of sustainability in aviation became a multifaceted effort involving technological advancements, operational improvements, and regulatory measures. The International Civil Aviation Organization, or ICAO, played a leading role in setting global standards for aircraft emissions and noise, driving the industry towards a more environmentally responsible future. The period from 1980 to 2000 saw the aviation industry take significant steps towards sustainability, laying the groundwork for ongoing efforts to reduce the environmental impact of air travel. The period between 1980 and 2000 was a transformative era in aviation. Technological advancements such as glass cockpits, digital systems, and advanced engine technologies revolutionized aircraft design, operation, and capabilities. The deregulation of the airline industry and the rise of low-cost carriers fueled unprecedented growth in commercial aviation, making air travel accessible to a wider population. Military aviation witnessed a technological arms race driven by the Cold War rivalry, leading to the development of stealth aircraft, advanced fighter jets, and the emergence of unmanned aerial vehicles. The end of the Cold War ushered in an era of global cooperation, fostering the formation of airline alliances and the rise of code-sharing agreements. These partnerships created a more interconnected and efficient global air transportation network. At the same time, the industry grappled with the environmental impact of aviation, leading to a quest for sustainability. The development of more fuel-efficient aircraft, quieter engines, and more sustainable operational practices marked a significant step towards reducing the environmental footprint of air travel. The advancements and challenges of this period set the stage for the future of aviation. The technological innovations laid the groundwork for further advancements in areas such as automation, digitalization, and sustainable aviation. The industry's growing awareness of its environmental impact paved the way for ongoing efforts to reduce emissions, mitigate noise pollution, and develop more sustainable aviation practices. The period from 1980 to 2000 was a pivotal chapter in aviation history, shaping the industry we know today and laying the foundation for the future of air travel.